Okay, so why do we need to know synthetic division or dividing polynomials? The first thing is this remainder theorem. And the idea behind it says that if I do division, which is this side over here, okay, and it doesn't matter whether you do synthetic division or long division, if I do, if I divide these two, I'm going to get the same answer as if I substitute in my solution of C. So we have our denominator, and we can see that C is a solution to it. So if I substitute that in, that will tell me what the answer is, or what the final value is for this if I divide these out. Okay, this is going to be my remainder. So let's look at an example. So here they give us a function, and they also give us the denominator. So this is x minus c. So we're going to look at it both ways and see that this is going to give us our remainder value. Okay, if we just substitute in f of c, so this is going to be, if x plus 7 is one of the factors, then negative 7 is my c value. So that means everywhere that x is, I'm going to substitute in negative 7. So I have negative 7 to the fourth plus 4 times negative 7 to the third minus 20 times negative 7 squared minus 39. Okay, when we multiply this out, negative 7 to the fourth power is 2,401. And then, whoops, not a plus. And then negative 7 cubed times 4 is a negative 1372. And then negative 7 squared times 20 is a negative 980 minus 39. And then if we plug all that into our calculator, when we get done, we end up with 10. So the remainder theorem says that if I substitute in my c, if I solve for c and substitute that into my factor, this should be my remainder. Okay, and let's check it. And I'm going to do synthetic division. You could do long division if you want to, and you'll get the same answer. Okay, so on the outside, we're going to put negative 7. And then our coefficients. So fourth power is 1. The third power is 4. The second power is negative 20. 1 is a 0. And then we have minus 39. Okay, carry the 1 down. Multiply, add those together, multiply, add them together, multiply, add them together, multiply, add them together. Notice I got 10 both ways. So the remainder theorem says if I substitute in my solution, if I find C, okay, then that gives me the remainder. Or I could do long division and get the remainder. I'll get the same answer. That is the remainder theorem. Okay, now the factor theorem with synthetic division says that if f of c is equals 0, okay, so if we can substitute some value c into a function and get 0, then x minus c is a factor, and vice versa. So these are just converses of each other. Okay, so notice here, this is the type of problem that I'm going to ask you to do. If you're given a function, notice this plus k. So that means we're missing the constant. So you have your function and you have your factor, and we need to know what is the value of k. If this is a factor, okay, if x plus 8 is a factor, then I know that f of negative 8, set that equal to 0, f of negative 8 is going to equal 0. So now I can do substitution. I can substitute in negative 8 for x and then set my function equal to 0. Okay, so let's see. That means that 2 times negative 8 cubed plus 13 times negative 8 squared minus 27 times negative 8 plus k has to equal 0. And then when we do the math, negative 8 to the third power times 2 is a negative 1024. Negative 8 squared times 13 is plus 832. Negative 27 times 8 is a plus 216 plus k equals 0. If I simplify, or if I combine all my like terms, I get 24 plus k equals 0. So k equals a negative 24. So that would be the value of k in order to make that a true statement. Okay, go ahead and try the check your understanding, and I'll post the answer link at the bottom.